In this lesson, we explore powers and roots, two connected ideas that link arithmetic, algebra, and standard form. Powers mean repeated multiplication, and roots undo that process. Powers appear in almost every topic. Simplifying algebra, calculating volume, working with standard form, and finding compound interest. A power shows repeated multiplication of the same number. The base is the number being multiplied, and the index tells you how many times it is multiplied by itself. For example, a to the power of 3 means a multiplied by a. For example, 2 cubed equals 8 and 5 to the power of 4 equals 625. A squared means I to the power of 2, and a cubed means I to the power of 3. After that, we just say 4 to the power of 5 and so on. Any number to the power of 1 equals itself. Any non-zero number to the power of 0 equals 1. A negative power means the number is flipped or inverted. This process is called taking the reciprocal. Instead of multiplying by the base, we divide by it. For example, 2 to the power of minus 1 means 1 divided by 2, and 2 to the power of minus 3 means 1 divided by 2 cubed, which equals 1 over 8. The larger the negative index, the smaller the value becomes. If you start from a squared and reduce the index step by step, each step divides by a. That pattern explains why a to the power 0 equals 1 and a to the power minus 1 equals 1 over a. Fractional powers represent roots. The denominator gives the root, the numerator gives the power. In general, a to the m over n equals the nth root of a to the m. You can apply the power first or the root first. Both give the same result. A to the 1/3 equals 2 because 2 cubed is 8. 27 to the 2/3 equals the cube root of 27 squared, which is 9. A root is the opposite of a power. It asks, what number was multiplied by itself to make this result? For example, the square root of 49 is 7 because 7 times 7 is 49. The cube root of 27 is 3 because 3 times 3 times 3 is 27. The number inside the root symbol is called the radicand, and the small number outside shows which root we are taking at, for instance, a cube root or a fourth root. Even roots such as square roots technically have both a positive and negative answer, though in GCSE we usually take the positive one. Odd roots can handle negative numbers, like the cube root of minus 8 equals minus 2. But even roots of negatives are not real numbers. When multiplying powers with the same base, we add the indices because we are increasing how many times the base is multiplied by itself. For example, a squared times a cubed means 2 factors of a multiplied by 3 more factors of a, giving a total of 5 factors altogether. That's a to the power of 5. This is why the rule is written as a to the m times a to the n equals a to the m plus n. When dividing powers with the same base, we subtract the indices because we are canceling out factors that appear on both the top and the bottom. For example, to the power of 5 divided by a squared means 5 factors of a on top and 2 on the bottom. 2 of them cancel out, leaving 3 factors of a, which is a to the power of 3. This shows why we subtract the exponents when dividing powers of the same base. When raising a power to another power, we multiply the indices because the base is being repeated groups of repeated multiplications. For example, if we take a squared and then cube it, that means we have 3 groups of a squared multiplied together, like a squared times a squared times a squared. Altogether, that gives 6 factors of a or a to the power of 6. This shows why we multiply the exponents when taking a power of a power. When we raise a product to a power, each factor inside the brackets receives that power. This happens because multiplication is repeated several times. For example, if we square the product 2 times 5, we are multiplying 2 times 5 by itself, giving 2 squared times 5 squared, which equals 4 times 25, or 100. This is why we can distribute the power across both factors. When a fraction is raised to a power, that power applies to both the numerator and the denominator. This is because the whole fraction is being multiplied by itself several times. For example, if we square 3/4, we multiply 3/4 by 3/4, giving 3 squared over 4 squared, which is 9 over 16. The same idea works for any power, positive or negative. Here we combine multiplication and division laws. Add the powers on top, Subtract those on the bottom to get 2 to the 5th equals 32. When we square a fraction, we square both the top and the bottom. Think of it as multiplying the fraction by itself. So 3/4 times 3/4 gives 9/16. The numerator 3 becomes 3 squared, and the denominator 4 becomes 4 squared. This rule works for any power, cube, fourth power, or even fractional powers. Always apply the index to both parts of the fraction. A negative index reverses the effect of a power. Instead of making the number larger, it makes it smaller by turning it into a fraction. Here, 4 to the power of minus 2 becomes 1 divided by 4 squared, which equals 1 over 16. Notice how the negative sign doesn't make the answer negative. It simply flips the number to its reciprocal. When a power itself is raised to another power, the effect grows quickly. Each layer multiplies the number of times the base is used. For example, 2 cubed gives 8, but when that entire result is raised to the fourth power, we multiply the exponents. 3 times 4 to get 12/2 to the power of 12, which equals 4096. It shows how rapidly powers can increase when exponents are multiplied together. Powers of 10 allow us to express very large or small numbers in scientific notation. 3000 becomes 3 times 10 cubed, and 0.0042 becomes 4.2 times 10 to the minus 3. When a root cannot be written as a whole number or fraction, it's called a surd. We leave it in root form for exact answers. To simplify a surd, look for perfect square factors inside the root. The goal is to take out any number whose square you already know. In this example, root 50 is written as root 25 times 2. Since the square root of 25 is 5, we simplify it to 5 root 2. This keeps the answer exact rather than using a rounded decimal. You can only combine like surds. 3 root 2 plus 2, root 2 equals 5 root 2. Modern calculators have dedicated power and root buttons. Practice entering both positive and negative or fractional indices correctly. Don't apply index laws to different bases. 2 cubed times 3 squared is not the same as 6 to the 5th. A negative index does not make the whole number negative. It creates a reciprocal. Remember that minus belongs to the index, not to the number. You cannot split a root across addition or subtraction. The square root of a plus b is not the sum of individual roots. Let's test your understanding. 16 to the 3/4 divided by 8 to the 1/3 equals 4. We converted to roots of 2 to make it easier. To summarize, when multiplying, add powers. When dividing, subtract. For powers of powers, multiply. For brackets, distribute the index. Always rewrite roots as fractional powers to simplify algebra and practice problems involving surds and powers of 10. Now, test your understanding. It's using the Powers and Roots quiz on Reko Study and reinforce everything you've learned today.